And done.
Fantastic. All right. Welcome to the data science learning community. Deep Learning for Coders, Part 2. We are reviewing video lesson 14. I forget what the what the larger title of Part 2 was, but basically it's building stuff from foundation. So we're
Right.
getting into more nitty-gritty detail with PyTorch. Uh, and basic mathematics, like how the chain rule works.
Something like
And
stable diffusion from scratch or something like that, I think, or something to do with stable
yeah,
diffusion.
stable diffusion, and then something from foundations or from
Yeah, that's
scratch or
what it is. Yeah,
whatever.
there you go.
Yeah, so we get really we started with very kind of modern techniques, and then now we're kind of back at the beginning, almost from lesson 1 or 2. And it almost feels like Jeremy is preparing us to like build the fast AI library, right?
Yeah,
I don't know. I just get that feeling. Um, it's pretty neat, to be honest with you, because we're building these like rudimentary versions of some of the PyTorch classes that are out there, and that's been instructive for me. I've had exposure to Python for years, but I'm not really someone that's like doing object-oriented programming on a regular basis. So this wasn't like the easiest lesson for me. Um, it's probably more challenging than some of the others, but I could still follow along. And I feel like most of the lesson was just like a bunch of random technical tidbits. And so I tried to internalize those where I could,
yeah, I agree with you there.
given the time constraints on this. So I'll just do I think we all felt pretty comfortable with the math, and so I'm not going to dwell on that. Although I thought that the opening piece where he's just talking through the chain rule and translating that back into some of his code was helpful for me. Uh, Pasted a couple code chunks from the last lesson where he's doing a forward pass and then a backwards pass, taking the gradient, and then essentially applying the chain rule and connecting, hey, this is the chain rule where we're starting from the loss function. Could be I think in this case it was mean squared error, right? And so you take the derivative of that mean squared error function, that outer function, um, with respect to I guess he's calling it the neural network output. And from there you take that another derivative, right, with respect to the input or to the weights or to the biases. And so that's what's going on in that top code chunk here. Um, so taking that outer derivative, if you will, like the mean squared error function where it's to the power of 2, you have to bring the 2 to the front, multiply that, I think by the 1 over the sample size, and then I guess the prediction minus the target, right? So that's this out G function, and it feeds into the gradient here. And I had to kind of think through this. This is the derivative of the biases, the biases vector, right? So it's
Derivative
technically,
with respect to that's what I finally realized that when you write b dot g, it's actually the derivative with respect to b. It's always a derivative of the loss.
yes, you're right. It's derivative with respect to B,
Yeah,
but it's two components. It's
right,
derivative with respect to that outer loss function, and then I think of it like the inner derivative, right, of what's
right,
inside of that loss function with respect to, and you with respect to the weights, with respect to the
right.
inputs,
I gotcha.
with respect to the biases. And so what, you think through what's in that inner, what I consider to be that inner function. It's like the weights times the inputs plus the biases minus the target. Uh, and so if you're doing the derivative with respect to B, what's in that inner function, if you will, that turns into a one, right? Or a vector of ones, right? If you're taking the derivative with respect to B. Um, and so that simplifies because you're multiplying that outer derivative, if you will, right? The loss function with respect to n, as Jeremy would describe it, times a vector of ones, that's the same as summing up the components.
Okay, yeah, I see what you're saying. Yeah.
So just trying to translate the math to the code was not super clear to me when I looked at this, right? It would have been more helpful for me to actually see like, oh, this is real or a vector multiply, or is it a
Right.
matrix vector multiply? But it basically simplifies to a sum at the end of the day. So I guess I had to think through that to get what was happening there.
Cool. Yeah, I
Yeah,
just have to write it out, like I said, like write it out in, as, with little summation symbols and some, it's math, not as a code to figure it out myself.
yeah, and of course this was a problem last week, and I think the last couple weeks just trying to understand unsqueeze where
Right.
you want the broadcasting to work, so you're adding a unit axis, I think in the second dimension, if you will, with the one, and then here you're adding one at the end with a negative one. Little confusing on the first go at this for me, but I think it made sense after spending 5 or 10 minutes with it. All right, and I'm gonna jump around to his actual workbooks. I think he was in three different workbooks over the 2 hours or so. Um, he talks about F strings, which I'm assuming you're very familiar with in
Yeah,
Python.
they're awesome.
Yeah, I was definitely a dot format guy for a long time, and I didn't really cross over to using F strings more regularly until I don't know, like a year ago.
They're not that old, right? The F strings are only a few,
I think you're right, but
I'm not
like
sure. And also
10 years.
different, yeah, people have been rolling, up getting the most recent Pythons rolled into whatever system you're working on slowly. So now it's pretty much every
Yes.
computer
Yeah,
use has it though.
I think it's the preferred approach, right? When you're trying to concatenate strings and
It's so fast and
yeah,
easy to write. Yeah.
definitely. Yeah, he talks about, another tidbit like, hey, you should be creating Jupyter shortcuts because a lot of times you want to run all the code up to a certain code cell and, you can do that just at the menu up here, but, you can put in a custom shortcut. That's just one of Jeremy's many tips.
No,
All
I
right.
must have missed that. I don't remember that.
Yeah, I think right. So it's not something that's just built in there like your standard like escape B to add a cell below or escape A above. You have to
Gotcha.
program it in there. I'm not exactly sure where that's at, but it's up there. Sh Shortcuts. It won't allow me to add anything there, but whatever. That's a simple Google search. Uh, okay, so then he takes us to notebook 4, and believe we went through some of this, or Torin went through some of this last week. The softmax function was something we talked about, and he had a little trick with this log sum XP, right? Because it was more numerically stable when you're dealing with large numbers. And so where we ended was with a training loop of the neural network, right? Like a basic MLP, running things through a specified number of epochs. What the forward pass and then this is really the backwards pass, I guess here, right? Where we're stochastic gradient descent we're doing on all the different
Right.
parameters. And so this week he starts with talking about the NN module. It's built into PyTorch. It's basically a pretty limited class overall that I think typically you're going to inherit when you're designing your own classes here. Um, he just sets this attribute foo, right, arbitrarily, making a neural network linear layer, 3 features in, four out. And it has this nice print capability to say, well, layer foo is this linear layer, and here's some of the items related to it. That module also has something called name children. Again, above, we just implemented one linear layer. So look similar to when we just typed M1 here. But we could certainly add another layer and it would print out that in a sequential fashion there. And then it has a parameter attribute, or I guess this is a method, because we got parentheses at the end here, which, what is this? This would be, I think this is the bias vector, and these would be the weights. And so, here we're making our own class, inheriting from that neural network module. Basically, we just have number of inputs, number of hidden layers, number of outputs. We use this super function because we want to inherit from the neural network module parent class. And then just manually within this class, creating a couple layers. In practice, right, we'd want to make this more flexible. But for this starter case, we're just assigning it a couple
Hang on a
linear
second.
layers. Yep, no problem.
I'll just mute, keep going.
Yep. And then a ReLU layer as well. And then defining a forward pass. So that's pretty easy to instantiate, a variable of this class. And when you print it out, again, this is part of the beauty of the neural net module pretty print, where you can see all the layers. And here we go, just kind of looping through the named children, looping through the parameters. And so with the benefit of this neural network module and this class that we just created, right? We made this model from that.
I'm back, by the way.
Oh, okay. Great. I just kept going. So basically we're at our first iteration improvement, right, on that initial training loop from before. Because we're using this neural network parent class, we don't have to manually do the stochastic gradient descent for all of these components here. So we simplify a little bit here, right? So for P and model parameters, we know parameters is, it looks like a method of that neural network class. We, instead of writing, a few lines, we can do it in just one. So for every parameter, we can do the gradient descent step. And then for the whole model, you got to set the gradients to 0. So whereas before we had to set that manually for for the weights, the biases, did we do it for something else? No, just those two. Here we're doing it in one line. So that is step number 1. Oh. And then he goes a step back, like, hey, like, what if there wasn't a neural network module class? Maybe we can design this thing on our own. And so that's what we attempt to do here with a my module. And so the key piece here is you have a module dictionary, calling it modules. Have the underscore in front of that, so I'm guessing it's supposed to be a private dictionary. Adding a couple layers as before. And this part was a little tricky. This is about storing layers of your neural network into this dictionary. And this was a little confusing to me, Ron. You've probably seen this a lot, but like it's referencing the super here, but there is no explicit parent class, right?
Right.
So what Jeremy says is really when you don't put anything there, it ends up being something like this object. I can't remember if that's a capital O or lower O. But basically there are some methods and probably attributes associated with that object class that's kind of invisible to us as users. And this set attribute, I guess, kind of exists everywhere. Like anytime you have a class you want to set like a .foo, right? Like we did earlier, what's happening is that set attribute dunder is or set adder is how Jeremy describes it, is happening behind the scenes. So we're overriding that here so that we can add parameters, right, layers of the neural network in a
Right.
dictionary. And then I think what we're doing with this second line is saying we still want the normal set adder functionality as well.
Right. So if you were to type K equals V there, it would just get a circular loop, right? We call back
Yeah,
the
yeah, yeah,
or
I think
self
so.
dot K equals V or whatever you have to, yeah, you write self dot K equals V, it would just call that same function you're in and you'd be in a loop. So you have to call the super to break that loop,
Okay.
which is where that's defined anyway.
Yep. Okay.
Probably not actually defined as in Python, but haven't looked, but I hope not.
Uh, and then there's this, we know that the neural network module prints out nicely whenever you just kind of, type the name of a variable, and that's due to this repr dunder. So we're doing something similar here using an F string. We're saying, let's just print out the dictionary, right? So all the layers of the network. And then we were also defining a method to print out, or I should say yielding, because we're dealing with, I guess, a generator, yielding the parameters of the model. And Jeremy goes into this yield from syntax, which is a little bit new to me. I don't think I've ever used that one before. I think without this yield from, there was like 2 loops going on instead of 1. I'd have to go back to the video, but have you
Yeah,
ever used this?
yeah, I have used it.
Okay.
It's just like a delegating your generator-ness, I guess.
Yeah. Yeah.
L dot parameters is a generator, so I just want to yield from that generator, right? That's all.
And so what he was doing initially is he had a loop with the L's, right? For each
Yeah, that's
L, or sorry, he had a P, each P in parameters, but after this first loop, so with this, it's just kind of looping through all of the individual parameters in
yeah.
each layer.
Although, is that not equivalent to if you just had yield? No, it's never be exactly the same. You could do a loop and then do a yield, but then it would be just a little more verbose, that's all.
And I think that's what he did initially. He had a
Yeah.
double loop instead of a return at the end.
I think it's only more concise, not more better performance, I think.
Sure. Yeah. Yeah.
And that's
He likes being very concise with the coding. I mean, that's kind of his point here, is to really to reduce the number of lines you need to get whatever you're trying to do done.
yeah.
Right. So we built this kind of homegrown class that's like the neural network module. When we print it out, you can see we've kind of manually included these layers here. So just layer 1, layer 2, both linear. That's pretty cool.
Yeah.
And then, with a loop, we can print out the parameters. And then we move on to what he's calling registering the modules. Really, I see this as, the more flexible way to add layers, right? You don't want that to be kind of hard coded in your class. You want to be able to put any number of layers in your neural network. So what he's doing here is just saying, here's a list, neural network, then do the ReLU, then another linear layer with a model class that inherits. Since we know how the neural network module works, the rules are we're allowed to use PyTorch now. He's going with that theme
Right.
for the last few lectures here. And essentially, yeah, we're specifying the layers, and then it's adding it to the dictionary and doing a forward pass. And then he goes into probably a 5-minute spiel on the reduce function, which is cool. I mean, it's something I certainly have used in the past, not all that often, but it's something that's common to, I think, most languages, right? The whole map reduce thing, where you have an input, feed it into a function. The output of that becomes the input for the next thing, right? Run that through the function. And so there's the, multiple layers of iteration that are happening there. And that's what's happening here to do the forward pass, right? It's like you start with one layer, you get an output. Layer one was linear, it fed into a ReLU, that gets an output, then that's being fed into another layer. And so that's it. You can do this more concisely just using the reduce function. Okay, so this is similar to what we saw up above. It's just a little bit more complicated. Our class is now more dynamic because we can just input any layers we want. And now we get to this point where it's like, well, this is the equivalent to the sequential model, which is part of PyTorch. So we don't need this homegrown model class anymore. And that forward pass can actually be done a little bit more succinctly without the reduce. So it's as simple as saying, I want a sequential model, and here are my layers, and those layers we just specified in a list up here. So kind of a one-liner to get that work done. And we're still using a fit function from above, I guess. Guess we didn't create a new one yet. But I think we're still getting the same output. Okay. Moving on, we're talking about an optimizer class at this point from scratch. And I guess I was a little surprised at how simple this really was. Right, you just input you're instantiating a set of parameters associated with your neural net and the learning rate, storing those, tucking those away, and then defining a method step to do the stochastic gradient descent. So for all of your parameters, right, you're going to take the negative of the gradient times your learning rate, and that becomes your new value of your parameter. Okay, and then right, as part of that training step, you have to set the gradients to 0. So that's what we're doing here. And let's see. Okay, this is similar to what we did before. This is just the neural network sequential. Using our optimizer class, we can just feed it the parameters from our model. Uh-oh. Why did that break?
Okay.
I just didn't run a couple of the cells above. All right,
Which
so
computer are you writing this on your local computer?
yeah. Things have been running pretty quickly. Like you, I have an okay GPU. It's just a laptop. It's a GeoForce RDX 2070 or something like that. It's got 8 gigs of RAM
But you're
on
not
it, so it's
using
not
it right
bad.
now because you're not moving anything over to the CUDA.
No, I don't think any of this stuff here really
It
does.
doesn't need it anyway. I ran into a weird problem with this where like it was taking like minutes for it to do this for me. And I just still don't know why, because I'm like, well, I don't know what's
Okay.
going on. Like I have two environments. One's I call PDL, and the other I call PDL GPU that has a GPU installation. For
Yeah.
some reason, running it on the one with the right CUDA parts installed, using the not sure what the right words are for that, but the ready for CUDA version of PyTorch in it. Using the CPU, I ran this in seconds, just like it does for you and probably for Jeremy and everybody else. But the other one, I just used the Fast AI installation, was taking minutes. And I was banging my head against the wall, and then I ended up just uninstalling the entire environment and reinstalling it, and then it worked.
Yeah.
I
Well,
have no idea what was causing.
yeah, that's never fun when you can't really identify what's going on there.
This is all in WSL2 as well, so I don't know if that made any difference. But
I'm in WSL as well because I think I've told you, I mean, trying to use the GPU on Windows just didn't really work well for me. I was better off just running in a Colab notebook, not using a GPU. But I get pretty decent performance in WSL for whatever reason.
I like using WSL. I'm going to use it for the Rust stuff too, because it's just a better development environment if you're used to Linux commands or Unix commands. Yeah, that's about the right speed.
Yeah, so that was pretty quick. And so what we've done here is we've simplified that gradient step right? Because we've encapsulated all that in our optimizer class. So we're basically just applying that step method. It's a couple lines of code here, and then that we need to zero out the gradient each time you're running through here. So our code is already getting quite a bit smaller than it started with. So now we've taught ourselves how to create an optimizer. So now we no longer need to use it. Torch has its own optimizer. So we will use that moving forward. So he just creates this little function where we're using that sequential class from PyTorch and then returning that model along with the built-in optimizer. And it has this method SGD for stochastic gradient descent. You put in the parameters and the loss ratio.
It's a beautiful thing.
Yeah.
It
Yeah.
is a beautiful
So
thing though, because now you build these things, at least today, I'm sure in a month it'll all fade away, but at least today I feel like, wow, I really understand what my George is doing underneath.
I think it's cool. Like if you
Yeah.
really get, I do think this is preparing us if you really need to do something custom, this is kind of giving you that knowledge where you might not want to just do the default stuff, right?
Right.
So
It also helps you
I
understand
appreciate
like
that
how to use the pieces better if you understand how they work, right?
for sure. Uh, for sure.
Oh
All
yeah,
right.
the data set section. This was
Going,
I have to be honest with you. This like I said for this section, this lesson was such a slog.
it was. I had to watch the video like 2 or 3 times.
Yeah.
It was tough. This data set class doesn't really do much, right? It's like we're taking in your X and Y, right? Your features and your target, um, defining the length of your input, and then this is just a way to index. Uh, I think that's what this is doing. Yeah, this is just a way to index
Yep, just a
uh,
custom collection. I mean, I think this
of
at this
your
point
X's
it's
and
just
Y's.
to show you how custom collections are built, but
But this kind of reminds me of those earlier lessons in for this course, right? Where he has those data loader classes. I think we're kind of getting to that.
yeah.
We were doing some of the image stuff, and that term, like a data loader, was completely foreign to me. And he kind of builds up to that. Yeah, so this is just making a data set, really. And you have a few attributes, some dunder methods associated with it.
Yeah, but I think at this point in the video, he does refer back to the Python data model again, where you can learn all these different, or is this where he does it? At some point he talks about all these different Dunder methods that exist in
He does
Python.
that a little bit later.
Okay.
Yep.
But this particular subset, length and get item in particular, are what you need to reproduce the most basic collection
And
class.
I think, his point here is that this something similar to this exists in PyTorch. So we're trying to reproduce that, even if it's a, kind of a toy example of whatever they have.
In PyTorch or in Hugging Face?
Well, that's a good point. I don't know, because he does kind of go on to both of those, right? And differentiates the fact that uh, PyTorch tends to use tuples and Hugging Face tends to use dictionaries.
No,
And so,
there's a data set class um, in PyTorch. So there you go. You're right. Map from keys to data samples.
yeah, I look at this thing and I'm still struggling a little bit to see the value of creating this. Maybe it will finally dawn on me as we go through this. Um, but the data loader does make a little bit more sense, um, because this allows you to actually chunk things um, into batch sizes, right? And I think that's the core of this iter dunder method, where we're just breaking things off into separate batches. And so we can feed this our train and validation data set, specify the batch size and it will chunk things out, as a generator. So in chunk fashion there. So, yeah, so now we're just kind of returning something from the XBs from our valid, okay, data set. Probably don't need to focus on that so much. All right. Trying to see, did we really do anything significantly different here? This looks very similar to what we did before, other than, we're using this line here that might be different, where we're calling the data loaders, sorry, the data set variable that was instantiated version of that data set
The
class. I think,
yeah, the data loader. Yeah.
yeah, I think that's kind of what's going on here. Yeah, the train DL, yeah, data loader. Right. So now we don't have to talk about batches. And before, weren't we? Yeah, we were doing things with like slices.
Yeah, that's cool. That's what
For,
the data loader takes care of for you.
yeah, so we were going, yeah, we're in range of 0 to n by batch size, doing slices. Now we've gotten rid of that altogether. So, our script here is getting, our fit function is getting pretty small.
But now we gotta
Okay.
shuffle them up.
Yeah. Now we got to shuffle them up as we go through our batches. So he applies a sampler class, uh, which really just returns indexes from what I remember.
Yes.
And yes. And then we can actually shuffle it here too if we set shuffle equal to true with the, yeah, random shuffle. Okay. I'm not going to spend a lot of time on that. I'm just looking at the clock here and
Yeah, it's fine. I mean, that'll seem pretty straightforward.
we'll get through as much as we can here. And then we have the batch sampler, which inherits the sampler as one of its arguments, and then it returns things in a chunk fashion. He went into this whole thing about this collate function that he's using in a bunch of other areas and pointed out that I think PyTorch and probably Hugging Face use something similar. It's not really doing that much. It's just taking your what are these your X's and Y's and making sure they're in a tensor format and stacking them together. And so he revisits that data loader class and applies that collate function. And honestly, I don't remember all the mechanics of it. I mean, I'm looking at it right now, but unless you have any questions, I'm going to just keep moving on.
Yeah, no, I'm fine.
Okay. And then let's speed things up, right? Let's take advantage of the fact that most computers have multiple cores. And so he's making an improvement here with that batching process.
Right.
You
Thing.
fed and where you can specify number of workers, which I'm assuming is the number of CPUs, right? So I think he just sets it to 2 here, but you could do it, 4 or 8, how many CPUs you have available to do kind of what we did before. And then of course, PyTorch, as always, has these same things that we just talked about. Random sampler, batch sampler, data loader, it's all there. So
And
we
you
don't
can
have to
shortcut it.
yes, we don't have to build any of this stuff from scratch. Let's see. I don't know if there's much else interesting here.
Well, the only thing is he does point out that, you don't need to, it had a lot of good defaults. Like you don't have to tell it the collate function, it'll use a good default. You don't have to tell it, even the batch sampler, it'll just say, you just say shuffle equals true, and it takes care of that too. So it's a lot of that details are kind of hidden away from you. Actually didn't even know they existed until this lesson. So
Oh, for sure. Yep. Yep. Okay. And so then he takes our fit function and then he says, well, we haven't really been measuring loss on the validation set up to this point. So our code actually got a lot bigger because it's just keeping track of that loss and the
Right.
accuracy on the
validation.
the validation set.
Okay, I just switched off my
Okay, now.
headset.
I hear you now.
Let me, yeah. Okay.
It wasn't sure it was me or you, so I
thing.
reset. I'm trying to get your attention in different ways.
Okay. I appreciate that. That's the second
Oh, dropped out again.
thing.
Dropped out again there for a second. I don't know what's going on there, but
Okay, can you hear me now?
yes.
Okay. All right, we'll just have to go with my computer audio. So I think
That
my
works.
headset.
I'll mute mostly so there's no echo. Well, I guess it won't matter as long as I'm not talking. I don't really actually hear much echo, so it seems fine. So you cut out right at the end of the last notebook.
Okay.
Which I think was mainly at that point just.
I see. Yeah, yeah, and I was trying to go pretty quickly through this notebook here. I mean, basically, he's trying to get us prepared for like, this is what a Hugging Face data set looks like, and some of their classes, their models tend to be based off of dictionaries as opposed to tuples or tuples.
Yeah.
So I'm gonna, go through this pretty quickly. We see another a collate function that we saw earlier. He introduces this transforms function, which I think can replace the collate function. Again, you're converting things to tensors. He mentions you can put in some of the data augmentation type steps you might want to do, like if you're dealing with images within this transforms function there.
Yep.
Yep. And then he spends about 10 minutes talking about like decorators, right? Yes. How you can modify a function with a decorator, which is, a cool concept, something that I haven't taken advantage of enough. I'm certainly aware of them and seen them, live in action, but don't use them much myself. And yeah, I don't really, he talks about this item getter and the get item dunder method, which was kind of interesting, but again, I felt like that was a bit of a side adventure. So I'm not going to spend a lot of time on there, just given where we're at in the hour.
Yeah, no, that's good. I think you're good with that.
Yeah. And so he he creates a couple more custom functions just to manipulate images, which is kind of cool. And again, this goes back to my whole point where it's like, I think he's probably doing a lot of this stuff within the Fast AI library for us, which makes things helpful. I thought this was cool here. Did you pay attention to this Fast Core library? You have this decorator and delegates.
I spent way too much time.
And so,
because I'm like, what does it actually do? Because you look at the code for it, it's kind of confusing. And I finally played around with it. I think I know what it does now, but go ahead.
So when you have some quargs or args, right, and you want documentation there, you can basically say, hey, my keyword arguments are part of the this IAmShow function. So then when you introduce your help or your question mark after the function that you created, it won't only show you the arguments that you explicitly put into your function, but also those potential keyword arguments that would be associated with these supplemental functions, right? Like in this case, IAmShow, which I think is kind of neat, to be honest with you.
Yep, you understood it perfectly. It took me a lot longer to get there.
Yeah, and that Fast Core thing is another Jeremy creation, so more of a workflow thing for him.
Yeah.
I mean, he's got a lot of cool ideas. And he does something else here too with this, and I think this is part of this delegates decorator. You know, you have your arguments here. You can specify the data types, and then if you comment out, you know, kind of what each of these components are, you and then use the nbdev library, import the show doc function. It will actually give you quite a bit of information about your function that isn't part of like base Python or anything. So, right, like here's one of my arguments and rows, right? It's an integer data type. It's default 1, and here's a text description of what it's doing. So, really cool feature that I've never really seen anywhere else.
No, yeah, so that's part of the nbdev thing. It's just it's using the type annotation, type hints, and the comments to generate docs. It's pretty cool.
Yeah. Yeah.
There's other
I like
libraries that do that too besides nbdev. It's like there's quite a few Python libraries for document generation, but
okay. Gotcha. Well, yeah, so I think that's most of the stuff in this notebook. Really, it's just about being able to pre-print images in a grid. And like I said, I'm pretty sure FastAI kind of does this for us. And I think he's just showing us his thought process, how he got there, you know, to these things that are probably completely abstracted away in FastAI. I mean, I don't know if PyTorch itself, like, does it do anything with images in this kind of fashion? If so, he doesn't point us in that direction.
Not that I'm aware of.
Again, I think FastAI probably does. Okay, that is most of the lesson. He spends a lot of time on callbacks, right? And I think the idea of callbacks comes from event-driven things where you're dealing with GUIs, and you want to press a button and have something happen when you press it.
Yeah,
I guess that's kind of where the idea of a callback comes from, just event-driven actions. And we're trying to bring this back to the, what we're doing here, training a neural net. And, while you're running an epoch, you might want to display a message. And so he goes through quite a few iterations of how you could have a flexible argument, right? A callback as one of your arguments. Your input could actually be another callback function, and that's what he does in a lot of these cases here. Right, if callback, implement that callback function. To say like we're on epoch, and you don't have to do that with a formal function. You can do it with a lambda function. Or he loves the partial function, so
yeah.
where you can partially fill in some of those default arguments.
That's really useful. Yeah.
Okay.
I do.
Yeah. So he's just building, more and more complexity onto that callable object. It doesn't even have to be a function. You can do something similar using a callback class. Here we have a call method, so it's kind of like a function. Does kind of the same thing here. And then he talks about args and quargs for about 10 minutes, which is a canonical Python concept where you have args, which would be non-named arguments, but they're specified by position, and then keyword arguments, which would be stored as a dictionary, right? Those are the named arguments, and sometimes you don't know how many arguments you're going to have. So this gives you some flexibility, right? To specify kind of like an unlimited number of arguments or keyword arguments.
Yeah, and those work both ways. So, you can use them the other way around. You take a dictionary, you start, and you call something else. It'll unpack it as keyword argument, which is kind of cool.
Okay, yeah.
He uses that.
And you use that?
I use that a lot. That's because he does use that. Before he introduced it, he used it a couple times.
Yep. He did, for sure. Yeah, we were just talking about it like 5 minutes ago.
Right.
And then he skips over this modifying behavior set of codes. He said it basically wasn't relevant, so I just didn't really pay attention to it.
I joined him with skipping over it as well.
Yeah. And then he talks about just dunder stuff, and we've seen a bunch of that at this point. So I don't know if this is like super helpful, other than like, you know, you can override default methods. We've already seen that, like an add class, right? Where obviously we know how to add like two numbers together, but like you can make your own add class that adds two numbers and then adds something else to it, like a default 0.01. And he's just kind of showing us how you would go about that. This get attribute function is something he kind of foreshadowed as something that we might be using in the future. But there's not really too much to it. Yeah, getters and setters. This is the getter.
I think there's also an attribute
and
thing that will go for. So set get attr goes after. If it can't find the argument, it'll call that. But attribute dunder will actually go first. It'll do you take over all the attribute access. You know what I'm saying? Like if you had an attribute, already had an attribute named A. If I say, oh, what's the object dot A, it'll give me the A. If I ask for B, there's no B, it'll call set at or get attr. Whereas if I had an attribute method, it'll actually override even the access of A. I think you have to call it super get attr to get at it. To get at it when you do that.
Okay.
Avoid the circuit.
Gotcha.
Pretty cool though.
So yeah, lots of different stuff in this video. Like you said, it was a slog for sure, because it's kind of like you're doing the same thing over and over again, making it slightly better. So like there's not like a huge payoff, but I don't know. I felt like I learned a lot, and as you mentioned before, just understanding the internals of PyTorch a little bit better, I think was one of the points here, and I feel like it was at least somewhat successful there.
Yeah, I see you skipped over, and so did I when I was doing it. The stuff about NBDev and generating the library. Or did he talk about this? Yeah, he did, didn't he?
He talked about exporting stuff. Right. He had this like mini AI module that's created here, right, with those hash pipes.
Yeah.
I think that was the primary use.
Yeah, as I say before, I don't like that style. It's I would teach his own, but I don't like the style of developing in notebooks mainly because the Git diffs are noisy and difficult.
Yeah, it feels like Jeremy's kind of an outlier there. He loves the notebooks.
Yeah, and he built an entire system to help him with that NBDev. So that's his system, right? Or his group. So yeah.
Yep.
I mean, it's fine. He does have the NBDev has a thing for doing diffs, and I actually use it to help me do notebook diffs, but it's not always available on every system I use. GitHub doesn't know anything about it. GitKraken doesn't know anything about it. So a lot of tools don't know anything about it. And there's ways to configure, but there's this extra friction, right? It's like
extra work, right? Yeah. So that's a problem for sure.
So I prefer just to use scripts when I can. Well, you're an R user, so you never had to deal with these notebook problems, right?
Yeah, I used to be a heavy markdown user. I don't anymore.
Our markdown's better though, right? Because it's plain text and it diffs fine. It doesn't have any rendered things in it. You have to render it every time, but
yeah, that's true. In one of these earlier lessons, Jeremy talks about Cordo, right? But he kind of abandoned that concept. He did anyway. Hopefully, I'm not making that up.
Yeah, he did talk about it. He uses it for some things. I don't know why he's not using it instead of using it.
Right. I mean, even like the data science learning community, I think isn't the idea that at some point we may transition to that?
Yeah, we're using Cordo
type things. Okay.
I think. Yeah, we are, yeah.
Cool. Very good. Now I'm just seeing all of your chats now. I can't hear you. I can't hear you. I just kept going. I'm really bad at checking the chats. So I do appreciate you doing a lot, Ron, to capture my attention.
All right, I'll type the end. Or you did already, okay, or stop, I guess works the same.
I did stop. Hopefully that works.
I think a lot of things work. It turns out during the Rust thing,